In this session we're actually going to look at variable types. Now variables are containers of which we can store information in. So we can actually create a variable, put some data into that and output that. So we have a limited range of data, and the main ones we're going to be concerned with we'll look at in this video. So first of all we need to declare a variable. So the word var means variable. It tells the computer that I need to open up some memory space to store some information in that. The next thing we need to do is actually label that space so we can actually call it back. Sometimes I'll refer to them as like buckets. So if you put a bucket out, you can put a label on the bucket. So if we wanted to, we could call that bucket S name. Now there's a reason for the S, and that's because when we put in a colon, we can actually then declare the type of bucket it is. In this case, we're going to actually store in there a string. So we can actually declare that S name is a string. And also string should be done with a capital S. It should actually be a reserved word, so it needs to be blue. So that declares a variable called string. Now there's other types of variables we can declare, and there's different types. We can actually have another one called a boolean. So we could actually call this B yes or B yes no, and then put boolean. And once you've got that, if you press enter, it will go in there. A boolean will be either yes or no. So there's no other options for it. It's either true or false. A boolean is very black-white. A string will only hold text and text type characters. A boolean will be yes, no, like a switch. Another one is a number. So we could actually put in there n number, and that will actually be a number. So that will hold numbers for us. Another one can be integer. Now number can actually have a decimal point, where integer, so I will put in here integer, and integer can only hold whole numbers. So therefore it can only have like 7, it can't have 7.2. Sorry, it should be int is the declaring of that. So an int is also lowercase rather than capital. So some of the ones we will be using are string, boolean, number, integer, and another variable type is an array, but we'll look at that at a later stage. But these are the main four that we'll be mainly concerned with. So a number in this case will actually store e.g. 123.321. In integer are normally stored whole numbers like 4 or 67, but they're not designed to hold decimal points. Now each of these are given a special name, and we've actually used a naming convention. Name is the name of the bucket, but I put an S in front of it. The main reason for that is so I know that S name will hold a string. B yes no, I could have called it B air conditioning, so if a car has air conditioning, yes or no, and I put the B in front of it for boolean, N for number, and I for integer. And that way I can use naming conventions, so I'm consistent in the way at which I label my variables, and we'll use a lot of these naming conventions to keep a structure in our programming, and it helps when other people come in and look at our code. Now once we've got this, we can actually store different things in them. I said S name's a string, so I can actually put some information into S name. Because it's a bucket, I need to call the bucket, so S name, and I'll just put equals. So therefore I'm going to put something in there. Because it's going to be text, I need to use a quote. I can actually put Leon Marsden. So you can put your name in there. And then if I wanted to, in the past I used to use a trace statement, and I would trace out quote Leon Marsden. But in this case here, if I want to know what's inside a bucket, all I have to do is trace that out. So in this case, we're using a trace statement to output some text. The text is stored in S name, so we're tracing out what's inside this bucket. At the moment it's got Leon Marsden, and we've put the right information. That's a string, so it can only hold strings. I can't put numbers in there. So when this runs now, I should get my name appearing on in the trace window, which it does do. So therefore, if I change the contents of a bucket and I put S name equals Bart Simpson, when I do this, it actually then puts that information into the bucket as well. And you'll notice, I need to close my program here, sorry. So when the program runs this time, you notice that Bart Simpson is the only one that appears, rather than Leon Marsden and then Bart Simpson. Because I've only got one output, it outputs the last thing put into the bucket. So when I first stored Leon Marsden in there, when I added Bart to the bucket, what was in there previously is lost. If I want to add more information to it, what I should have actually done is the following. So what I might do is I'll trace those out as a block comment, but I'll copy them first and I'll trace those out. This time I'm going to add to the trace statement. So this time I'm going to go sNames equal to sName plus Bart Simpson. So take the contents of sName, add Bart Simpson to it and store it back in sName. So this way whatever was previously in the bucket is here, and I've added to the bucket and then I've put it all back in the bucket to be displayed again. So this way I don't lose my previous information. So we should actually see Leon Marsden, Bart Simpson appear on the stage. So when it runs this time, you see that they're together. You notice that there's no space between them because we didn't allow for that. If we wanted to tidy that up a little, what I could either do is put a space at the front of Bart or a space at the end of Leon Marsden. I'll just put it up by Leon. So when it runs this time, you notice it's got them on the same line. Now that's all coming out of the same bucket. If I wanted to, I can actually put the names in two different buckets. So up here, I'm going to put in a comment now. I'm going to put variables, declaration. The reason for this is so that up here of my variable declaration, then the next part of it is my input. And then if there is processing, well at this point of time we could say that this line here is our processing. So I'll break this up. And then the last line I can actually have my output. Now this is a good way to do your structured programming, where you declare your variables, collect your information, process your information, and then output the information as an end result. And if you follow this structure, it helps keep your programming in order. It helps people debug, also helps you work through problems logically in an ordered fashion. So we've got different variable types and we can add them and output them to stage. So if we wanted to, we could actually change boolean yes, no to male, female. So if we wanted to, we could actually store that as a variable. So in my input, I'm going to change my name and then I'm going to have be male, female. Now there's no rule about variable names except for you should start with the variable type and then the name. The more descriptive you can be in your variable names, the better off your programming is, because then people be able to follow it very easily and they know what's being stored in there and what it's for. So in this case, be male, female. So if it's going to be true, it'll be the first option. If it's false, it'll be the second. So in this case, it'll be true. And you notice it's a blue word, which is reserved. So that turns that switch to yes. And if I had false in there, then I'll be considered the female. So when I trace that out now, I can actually trace and I can use a compound statement. I can go male, quote, space, quote, and then I can actually output the contents of that. So to cheat, I'm just going to copy this rather than typing it out all the time. And I can paste that in. And that should now give me the flag true in there. So male, yes, it'll be true. If that was set to false, then it will come up false. So in our runtime view now, Leon Marsden, Bart Simpson, male, true. So I want to correct my output at the moment. You notice I've got Bart Simpson in there. I no longer want Bart Simpson. So what I'm going to do is I'm going to run this line statement out. and I'm going to bring my other one down from up here. So I'm just going to copy that and paste that into my output area, or my processing area, sorry. Well, really I can activate it properly. Just delete that. I'll just reactivate it in my sname areas by removing my comment flag. So it declares Leon, and then it has the information. I've remmed that line out, and now I've got a duplicate, so we can actually put that back in, sorry. So this now should have the correct output. There we go, Leon Marsden, male, true. Then for a number, we can actually put something in for that. So in this case here, the input could be n number is equal to, and we want a decimal point number. We could have, you could have something in the way of height, like 180 or 1.86, and it could be meters, so we could have it like that. But when we go to output this time, we'll come down here, we'll put trace n number, and we'll join those up together so we don't get the error. And when we trace this time, we might actually get an error. Right, we got the 186, so that worked correctly. Sometimes you will get an error when you're trying to talk to an output window. This is actually text, and sometimes you have to change it from a number into characters again, but we'll deal with that another time. So once we've got that, we can then move to integer. So we can actually now say I integer is equal to, and we can put 1, 3, 4, 5, and we can actually output then I integer. Oh, sorry, typed something wrong there. So I integer, try that again. There we go. So all our outputs working. So there are different variable types and using them in the trace window. So you can see also in here we have a structure of variables, input, processing, output, and it helps us keep a nice structure to our language.